So now in this video, we have an op-amp current source. There is the circuit. I covered it in the last video. We're not going to go over it too much. I want to make it clear. This is a multimeter video. Not as much what this circuit is, but it's important we understand what this circuit is doing. So it's a current source. So first thing we're going to measure is current. I just need to set this to the milliamp range. I think you can go up to 600 milliamps in the milliamp range, and we're going lower than that. So whatever the maximum current you can set, or whatever the maximum current is of the setting, you want to make sure you measure below that. If you go above it, then you can blow a fuse. Be aware of that. So if there's numbers, make it a number higher than what you can expect. So I'm going to try to get about, we have 10 volts at the power supply, try to get somewhere around 3 volts across this LED. So doesn't really matter exactly what it is. I'm going to shoot for 3. We do have 3 milliamps on the power supply. It's not as accurate as a multimeter, which again, we could measure, but we also have about 1 milliamp of current going through that 10K trim pot because we are using 10 volts. And if I take too long, the meter is going to start beeping that I've left it alone. So I'm going to take this LED. So it's going from the output to the inverting input, and which we need for a current source. And I'm turning it around. So the long lead, the anode, is still to the output. Now the short lead, the cathode, is up one row instead of down. You have to make sure current goes through them in the right way. And of course, we got, close to 0 milliamps of current. Probably 1 milliamp flowing through the circuit. But again, this is not as, the power supply is not as accurate as a multimeter. So just be aware of that. Now, this resistor is headed towards the negative supply. It's a 1K resistor. For every volt across it, we can expect about 1 milliamp of current. And there you can see we got 2.5. Let's just round it off right there. Now, I could take the blue LED first. I'm going to bypass the LED, just come to the output, and you can see the same current. So the current's not going through the LED anymore, but it's exactly the same according to the multimeter. There, I could remove the LED. So it's a current source. It sets current. That's the most important part of the circuit. We have the trim pot so we can adjust the exact amount of current. But otherwise, you have a current source. So it should work on Ohm's law. Again, we have the cathode up higher. Normally I put it down lower, but I got it turned around that way. So if I measure the current through the blue LED, should be exactly the same as you can see there. We have a good current source. That may not have been the exact current we were shooting for, but even as the load changes, no load or a blue LED versus a red LED, right now we have that same amount of current flowing through it. So now that scene went well. That was actually just the first time I shot that scene. I'm going to keep it. So I'm going to set the meter back to a milliamps. Again, it starts beeping if you let it sit too long. And it's wasting battery if you do. We still have the blue LED there. This is a 1000 ohm resistor. So again, it goes by Ohm's law. We got the voltage that we're setting, and so that's going to be the voltage across the resistor. Makes its way to the resistor. The output has to go up a little bit higher than that to get the voltage to power the load, but otherwise it sets it across the resistor. So 1 kilo ohm, so we probably had about 2.5 volts across that. This is a 510 ohm resistor, so slightly higher than I want, but this kit doesn't have 500 ohm resistors, and I don't even know if I have one somewhere else. I bought a bunch of different resistors. But again, 510 is a common value. We got that. So we have the same voltage now, as long as nothing went wrong, across this resistor as that one. If it was 500 ohms, now we could expect pretty close to spot on 5 milliamps of current going through here. About 2.5 volts across it. So yeah, I'm going to swivel this around again. Long lead, the anode, is still to the output of the op-amp. But now we're going to bridge the gap. Instead of going right down to the inverting input, the -1, we are going to go up and then bridge the gap with the probes there. And unfortunately, I'm kind of pressing on stuff. But yeah, there you can see. Again, it's going to be a little bit lower because it's 510 ohms instead of 500. I'm pretty happy with those results. I'm going to bypass the LED. I could just yank it out and go directly to the output, but there you can see the LED builds up about 3 volts across it. So right now the output is providing the voltage that we need, probably 2.5 volts. When I add the LED, it's got to provide about 3 volts more than that, so probably 5.5. Hopefully that makes sense. I'll remove this again. We could just take the measurement directly to the output, and so I gotta be a little careful I don't go to the input there as well. But in any case, not a big deal in this one. 4.93. We should have the same with the red LED. Make sure you put it in the right way again. Cathode is up higher, and there you can see exact same current. When it's a current source, you know, things can kind of go wrong. There's things you don't factor in and whatever. But the main takeaway is a current source, the load doesn't throw off the current as long as you stay within limits. Of course, we got 10 volts at the power supply. The output maybe can only go to 8 volts. I think I'm going to measure that next video. This video we're focused on the current. Next video I plan to measure voltages. So whether it was a blue LED, the red LED, or we go right to the output, because right now we're just bypassing the LED. It's like it doesn't exist. We got the exact same current. That's what you want in a good current source. And an even better current source would be if you know, I took the exact resistance, the exact voltage I wanted and everything, the exact resistance of that one, and for the exact voltage that I'm setting and everything, if it all lined up perfectly, then the circuit as a whole would be a really good current source. But just the fact that it provides the same amount of current with different loads, completely different loads, nothing versus dropping 2 volts or even 3 volts, we got the exact same current. That's what we want. So in any case, a multimeter practice video whenever you're learning about circuits. I'm going to put this in the right way so it's the actual circuit. Whenever you're learning about circuits, they're talking about voltage and currents, unless it makes perfect sense what they're saying, and even then sometimes. Actually take the multi-measurements and look for yourself. It will help you learn that circuit a lot better, and electronics in general. So in any case, thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see ya in the next video.